Our next speakers are Sri and Gokul. Please welcome them. And they will be talking about their conference and using Kafka Flink. So,
Thank you. Thanks, guys, for joining in. It's a great honor. Hey, my name is Srivalsan, and I work as a cloud architect in Amazon Web Services. Since it's being recorded, all of the views which I share are pretty much on my own. I don't represent the company in any way. And I have with me Gokul, a consultant in Stepstone, and we are going to talk about real-time data processing using Flink and Kafka. How many of you guys have worked on Kafka, Flink? Is that only for, so how many of you have worked on Kafka? How about Flink? Okay, so that's it. So probably it's going to be useful for a lot of people because a lot of you have not worked on Flink. So it's quite curious if a lot of people have actually worked on Flink. I'm going to have a lot of questions, but and I'm covering the Kafka part, he's covering the Flink part, so it's a lot better for him. So cool. Before I start off with the agendas, probably just more the agenda. So what we're going to do today is I'm going to cover Kafka. What is Kafka? How does Kafka works? What's the architecture of Kafka? And how is Kafka differentiated from the other streaming apps? And what essentially is streaming? How is it actually different from the batch processing? And I'll probably hand it over to Gokul, and he will cover what's Flink, how is Flink different from Spark, how is it different from Spark streaming, and how does the Flink internals works, and how you and the use cases of how you kind of use Flink. Cool. And we'll take the questions at the last, so that we can actually just make sure that we'll finish it right on time, and we can actually take the questions at a later point in time as well. And by the way, it's Gokul's first talk, so go easy on him. If you don't go hard on him, it's fine. Cool. Yeah. Thanks, guys. Moving on to Kafka. What is Kafka? Well, that is Kafka coming to picture. It's basically an open source distributed platform, which is essentially used for queuing. And Kafka kind of came into picture when there was a lot of need for event streaming apps. When we talk about event streaming apps, if there's a series of events which are being generated and it needs to be processed, and you have quite a lot of apps right now from the queuing world where we were using JMS. Kafka came into picture to kind of address the capabilities which are quite needed for event streaming, and that's where kind of Kafka comes into play. So what Kafka does is Kafka is more of a topic solution as opposed to a queue solution. For guys who kind of don't understand queue and topic, queue is basically a message in and a message one. Topic is essentially a publish subscribe, which is like a producer kind of publishes into the topic, and you can actually have as many subscribers in actually subscribing to that message. And then you also have the concept of a durability and non-durable subscribers, but we're not getting into that at this point in time. So what Kafka, beyond the dynamics of high throughput, reliable delivery, which is pretty much there in many of the services, and how it actually kind of calls out. What I'd like to kind of touch upon is for everybody's benefit, how does Kafka stands out, and what do you kind of do with Kafka? So let's talk about an event streaming app. We are kind of generating multiple event streams. Let's talk about a cricket score or an NFL score, which are kind of monitoring. You have like 3 matches which are actually happening seriously, and you wanted to make sure that you get the latest score at any point in time, which is, let's say if, for example, I hope everybody kind of watches football, so I'll probably take a football example. So you have a foul, you then have a free kick, and a goal is basically scored on a free kick. And when you're actually watching this match, you have to make sure that the events are actually generated in the right way, and the events are actually shown the same way, which is you should basically let know a foul has happened and a free kick and a goal is. If you probably switch it the other way, where when you're actually watching a score, suddenly you see that a goal is scored and then a foul is actually happening. So it doesn't make much of a sense. So what you kind of need to make sure is the order of messages should be reliable, and what you also need to make sure is if there are other matches happening, it does not kind of conflict with the messages that are being delivered in Kafka. So what Kafka kind of does on a large scale is what you have basically partitions which are defined in Kafka, which essentially is a partition kind of make sure that a particular series of event falls into one particular partition. So the concept of Kafka kind of revolves around your partitions, which is essentially you could look at as a separate set of partitions which actually handles one set of events. So in this case, a particular football match scores goes into one particular partition, and you can actually decide a partition key, which is what is the key which actually separates the messages from one partition to the other partition. And you also then have a series of consumers who actually consume those. So what you then have is a series of partitions, and then you basically have a broker. And what Kafka also kind of does is it makes sure that the message is actually highly reliable, which then means that the message is actually replicated across multiple instances, so that you do not have the message is not lost at any point in time. That's essentially what Kafka kind of provides. So I'll have a slide which talks in detail about how the messaging kind of goes. Probably moving on, what we also have is, so it's pretty much used for much scale, high scale production applications. And what you also have is, as I kind of covered earlier, it basically used to process stream of events, and you can actually use that to join and aggregate messages. And what Kafka also provides is, it basically has quite a lot of libraries in terms of connecting to Kafka. So you have quite a lot of Kafka client libraries when you talk about connecting to multiple apps as well. So in terms of producing library clients to kind of connect to Kafka, and you also have consumer client libraries which can actually use to connect to Kafka. One thing I kind of would like to call out when we are kind of using Kafka is, I did speak about partitions, but one thing which kind of we need to realize when you're actually working on partition is, when we are building Kafka, what we also need to make sure is the messages in the partition should be evenly distributed. And that's something which we need to kind of take care when you're making sure there's a partition key which is being measured. And then when it comes down to how do we order the events, and that's where the processing agent kind of comes into place, where if you're kind of using a Flink in that case, what you have is, of course, you do expect the messages to be in certain order on a Kafka stream, but you have the data processing applications which basically supports a certain level of ordering as well. For example, in terms of Flink, you have things like watermarking or tumble windows, which actually kind of allows you to make sure even if the message is not ordered in the right way, you can actually look at the messages in the right way and then process those applications. So even though Kafka supports a stream of messages in the right order, what I would call out is, do not expect Kafka to kind of do that for you, and it needs to be handled on the processing application which kind of does the processing for you. And that's where, based on the use cases, you do have multiple ways in which you can actually touch upon. And I think Gokul kind of touch upon what watermarking is and things like that. Moving on, just to kind of touch upon how the architecture kind of works. So what Kafka cluster basically does is, you have multiple partitions, and is it all right? Cool. And so you basically have multiple producers publishing messages to the Kafka cluster, and as I explained, you have partitions which actually experience partition key. What you also have is, when in terms of consumers, you can basically group the consumers into a certain group, a consumer group, which is, rather than one consumer listening to a topic, you can actually have a set of consumers, which is basically established in a consumer group, and you can actually have those set of consumers consume the messages from the particular topic. So that's on a high level how the Kafka architecture kind of works. So if I move on to the things which I kind of covered, I'm just conscious of the time. So this is, for example, on a producer, so you have multiple producers which basically publishes messages to the Kafka cluster, and again, the way how it actually goes into the partition is how you define the key as. Like, for example, if the match is a particular key, Kafka then decides what is present on the message, and based on the key, it kind of publishes into the right partition, which is then picked up by the corresponding consumers. There's another slide. Just want to make sure that there are enough use cases for Kafka, which can be used for multiple of these services. I don't want to kind of touch upon all of these things. Just want to make sure that there's a high-level view of that. And so the other one, so just on use case perspective, what you also have is, so if you look at from a microservices architecture, this is just a high-level example of how it actually works. So you have a Kafka cluster, and then you can actually have let's say a microservices architecture kind of pushing across application logs, which is used for log processing, and then you have digital platforms publishing the health status, which is all goes into different topics and different partitions, which can then be associated with multiple consumers kind of consuming those messages. So that's essentially on a high level how Kafka works. Probably I'll hand it over to Gokul, who will kind of cover upon how Flink works and how you can actually use Flink to process event streaming messages.
Hi everyone. I'll be actually covering about the Apache Flink. And so before we get into that, so what is an Apache Flink? So I think most of it actually use Spark SQL or Spark. And if you want to actually live, you want to see the real-time data, I think the Flink would be the right option. Because on a Spark, Apache Spark, what you can actually do is like you can actually batch process. That's the one which actually mainly supports. But with the help of Flink, you can actually process the real-time data and with the sub-second latencies. That's and one of the use cases is what we can actually use is like, for example, the credit card transactions, finding and identifying a fraudulent transactions on a credit card, and then you're going to actually go and make a transactions, or somebody actually steal your card, and they were actually making a transaction within a minute, the cluster of transactions. And with using actually Flink, you can actually detect that, and then you can actually temporarily freeze the card. Okay, and that actually happens in a very real time. And there are other use cases in which we'll actually see it in the later part. But before that, so what is the Flink? The Flink is the open source streaming processing framework, and it is actually the fast, reliable, scalable, and it actually has a high throughput, and it can actually it can process both the batch and as well as the real-time data. So what is that? It can actually process the bound and the unbounded data. So what is the bound data? So bound data is before you actually start with any query or any sort of batch you want to take it, what is the start and what is the end. For example, the table APIs. Okay, if you want to write a query and the end results, like how many records you're going to actually get, how many records you're going to actually process it. But if it's an unbound streams, and you never know, you have a start to it, but you don't actually know the when is the end. For example, the carting, you actually have a sequence of events where you actually choose the events and then you order it, and then you never know actually, you have to actually wait for the other events to actually come in. It's not a very defined one. Okay, so moving on to the next one, yeah. And yeah, so these ones, it actually processes every record in once, and it actually ensures that, since it actually processes once, and it ensures that there is no duplicates within the system, and it actually manages engine. And yes, setting up the Flink data. So since so from my background, and we actually mostly use the AWS, and we actually go for a managed service, and we haven't actually extensively used the Flink, but we have actually started with that. We have actually trying to move from a Spark to actually Flink. And to prove that, so the real-time experience, what we actually want to see the data on a specific systems and a specific team, they want to actually see the real-time data. So that's one of our use cases, and that's where we've actually moved towards the Flink. And on the recovery part, recovery and the memory management, and it works pretty much similar to the Spark engine. So it's actually processes everything on the in memory. And since it's actually compute, everything is on a memory, and you don't need to actually go to the disk and then you actually get it, and everything is actually on a local. And the computation power, it's actually it's tremendous, and then you can actually process trillions of transactions, and based on the use cases, and you can actually spin up the nodes and the task nodes really very quick. And 1,000 nodes actually runs on a parallel and a distributed way. And this is some of the use cases for which we can actually use it for Flink. And so I think the previous speakers, they've actually covered about the ELT and ETL, and so what is the current data warehouse and what's the structure they have. And on this, you can actually have OLTP systems. You can actually get into transactions, or you can actually capture multiple sources like this change data capture on a database levels. You can actually use that any applications, for example, the insurance domains on a banking domain, any data you want to actually, on a click streams you want to actually see, you can actually capture that, and you can actually use the Flink to actually process the data. And one advantage you actually have with the Flink is like, you can actually process the data till the end, and you can actually do the enrichment part as well. on the if you want to actually run the model, previously what you actually have is like you actually have a dedicated ETL system and then you actually process it. But using a Flink, you actually capture the data right from the application, and then you can do the transformations, and then you can actually load in the database, and as well as you can load your model as well. Okay, so that way I think you can actually skip one layer of the code where you actually maintain all your data warehouse. It's still actually good practice to actually maintain and then do a reconciliation and then see what you actually get from the source. But based on your use cases, through the model and the predictive analysis, and you want to actually see what's the behavior. For example, the transaction systems, what I mentioned, for that, how they actually identified is like I have a set of pattern which I actually transact, say high value transactions. And for a month, so I have an average of transactions, say some X amount, but it actually, crosses the limit within a say few hours, and that's going to actually flag as a risk transaction. And the risk team, so they're going to actually do it very next day before you actually release the funds. So if you actually use the Flink, it'll be like very quick, and then it can actually alert the customers as well. You get a text message, and then you on the banking app also you get an alert. I think it's actually in the progress. But for that, the Flink will be the very, very good actually, the tool to actually use that. Okay, and it actually has a save and the checkpoints as well, and actually stores in the persistent local warehouse. That's the engine for the Flink. And so what it actually does is like, if you're processing and any glitch actually happens, and then you actually, any nodes actually failed during the process, and you can actually, come and, start from where you actually left off. And the engine is actually intelligent enough to actually, even if any failure actually happens, it can, the resource manager is going to actually allocate into the different nodes. It's going to actually handle it pretty similar to like the Spark, how it actually does. And since it actually runs on a parallel and it actually gains you, the computation power is more, and then you can actually process on a sub-second latency. So, yeah, moving on to the next one. Yeah, for the what do you actually have for the developers, and what are the languages actually support? Before actually Flink, they started with that with the open communities. So we actually had only two languages for the support. One is Java, another one is Scala, and I think recently we have actually had the Python PyFlink as well, and you can actually code on that Python library. But when you compare with, if you ask me like, because the Spark is actually more mature and you have all the libraries what you actually want to actually connect. But here I think on the Flink, it is actually, it just started with that, it's picked up the pace, but it's still, there are a lot of actually work needs to be done, or we can actually contribute more onto the Flink libraries. But whatever the available libraries, you can actually, connect for all your models, and for the developers, it'll be like, it'll be easy to actually connect with the existing libraries and with the tools and the HTTP, whatever the disk space or the storage, the S3, it can connect to the S3s, STFS, so it can actually connect to the most of the the available resources. And for the here, if you're really good in SQL, you can actually go with the SQL transformations as well, and you can actually write your code on the SQL, and then you can actually process it. And if you want to actually do the table APIs and the table joins and aggregate, and still we can actually do it on an abstraction layers. And if it's event streams, so where you want to actually capture all the events, the data streams, from an application or from a database or change data capture, I think you can actually capture all the streams on their data stream APIs, and it can actually handle the process functions, and the key feature is like it can actually handle the late data arrival, and it can actually wait for that, and it can automatically process the data for the late arrival data. So one such example is the carting, and you can actually go for the tracking till the point until they deliver the package. Yeah. So moving on to the next one. Yeah. So there are three important the use cases where we can actually see using the Flink. The one is like the data pipeline applications. Another one is the data analytics part, where you actually process all your models, and that is the last one is the event-driven applications. And let's just quickly jump into that. Okay, so on this data pipeline applications, you have a periodic ETL. That's I think all the previous speakers actually covered about the ETLs. I think everyone actually had a fair idea about that. And so you have this OLTP system, you do a periodic job or a polling job on a hourly basis or 4 hours, or so based on the need and the frequency, you actually derive that. And but what the Flink is going to offer here is it can actually process the real-time events. That's what I was talking about. So what you actually do is, like, you get it from one source, and then you actually load into the staging layers and multiple semantic layers, and then you load the data into the database and you wait for it, and then you again do the batch processing using a DBT or any other tool for that. But here, if you actually use the Flink, you can actually capture the live events from the system directly. Instead of getting into the transaction database, you can capture the events from the application itself, and you can actually ingest from multiple sources, and you can do the transformations and computation in memory, and then you can actually still, if you want, you can actually send it to the multiple data sources. It can be like the file system, or it can be to the S3, or it can be to the database, any database system which you want it. And further, if you want, you can actually process, and then you can actually create as a data lake or a data model within that. And one thing I want to actually highlight is the latency part, because on the periodic ETL, what you actually get is, like, we always have that. I think the previous speaker mentioned that there is a 30 minutes delay what you actually have. Even if you actually schedule everything, all the events, you can't actually have it before at least the 30 minutes, So you need to give the time. But in this, you can actually see your real events. Maybe the timings would be like, very few seconds, delay. And you can actually keep the aggregation and the state part, or the computation part, very simple. So that will be like really quick for you to actually see the data in your model. And yeah, so on the data analytics applications, it is mostly on the batch. So it actually comes from your warehouse, and from your warehouse, you can actually spin up the model, and then you do all the complex modules, and then you create the cubes on top of it, and then you do the models on the top of it. But here, if you use the data analytics, the Flink is actually first designed just to process one of the streaming applications, but later it actually helped to process the bounded streams, which I mentioned, the batch process. And that's where it will be helpful on the data analytics part. Even on the database, you can actually create an event out of it. If it's using an AWS, you can actually create any Lambda function to actually trigger that, or a Kafka streams. And it actually Flink actually works very well with the Kafka streams, and can actually read the stream data, and then it can actually process the data into the database, or really at really fast pace. And so here. So here the data changes on the data changes faster than the queries, and for example, in any company you take it, the finance team or actuaries or the risk team, they want to see the data at least with very low latency, because that's what their end of the day need. But if you just see all the traditional systems, what we have currently is at least you have a 4 hours a delay, or a 2 hours or 1 hour delay of data, what you actually see from the live system. And with the process data, I'm not actually saying just the raw data, but with the process data, you can actually see at least there'll be a minimum delay. To avoid all those delays, I think we can actually use the Flink, and then they want to see the model. They want to see the model in a computed way, and it should be ready to actually use the data for their analysis. And this will be the right approach. And if your use case is right, I think you can actually go for the Flink. And with the last, the event-driven applications. This was the one I was actually. These events can be actually triggered from Kafka or your applications, the insurance, or the banking applications, or your click streams, or so all the big techs already actually implemented that. One such as like the Netflix and Uber, they're actually using the Flink for that, captured all the event-drivens, and then they do the computation on the fly. And then since any events actually it's triggered, and then you can actually capture it, and then you can actually use the Flink system to actually process that, and it can actually supports on the periodical writes as well. And then since it actually has the save checkpoints, even if in case of any failures or in case of any default, it can actually it can actually resume really quick, and then it can actually log the events into the different set of sources. And it can be, as I mentioned, it can be the multiple sources where you can, if you want, you can actually load the data. I think that's it from me. Sri, you wanna cover anything? That's pretty much it. Okay. So yeah, we're open for the questions. Yeah. Thank you.
First of all, thanks both for that presentation, and especially you because it was your first one here, so brilliant. I guess I'm just going to ask some questions about the use cases. So you have mentioned that if you've got this kind of stream, so I'm guessing like if it was a Kafka stream or something, you would then use Flink to process that. So you're effectively doing like a micro batch or like ETL type thing. So I can see on the right hand side that you've got like persistent storage.
Yeah.
How do you see this tying in with the batch processing? Because normally in a business you would have both type of workloads. So how do you make sure that you're getting the best of both worlds basically?
Okay. Yeah. So what we actually have on the on our system, so I can actually because since I've actually used my environment and the system, so how we actually separate that is like based on the use case, which team actually wants what type of data. And from the Kafka, so we actually have multiple producers, and so we'll actually have multiple consumers, and we can actually do the filtering based on the so what type of data you're actually interested in. We don't actually want all the data which is happening based on a transaction system or anything. So we'll actually filter only on the certain consumer, and then we actually create the. And it's the background how it actually runs is like we set up the DAG, and then the Python code actually runs on the DAG, and then it actually processes at the background and with the Flink engine. And so to answer to your question, we just actually segregate based on the what we want to actually consume and which team want to actually see what type of data.
Sorry, just to add on to that, how we kind of differentiate the batch and streaming application. It again comes down to the use case. I work with customers who have batch apps and who have got real-time apps as well. And that's just one difference between Spark and Flink. Spark also kind of supports Spark streaming as well. But the major difference is Spark works a lot more on batch processing. So even if you look at Spark streaming, what it's essentially trying to do is it's basically breaking down to micro batches. And so it kind of works on more micro batch interval and then works on it. But if there are use cases where the customer wants to have real-time events being processed, and that's essentially where Flink comes into picture. So if you are looking at a batch processing app, personally I would suggest to kind of go for Spark for a very simple reason that the Spark library is a lot more advanced, and Flink is more, right now the Flink is more focused on real-time processing, and the other use case would kind of comes down to is how do you make sure that you are actually processing the events on the right sequence, and that's where watermarking. So there's this concept called windows, which I kind of missed on the slide, which is if you have a series of events which are actually coming in, and you wanted to make sure that you process the right events first, and that's where Flink also provides a view called windows, which is you have windows like tumble windows, and you have the session windows, which is like you can actually define a duration of events. So rather than looking at the event or the right go and then processing it, what you can actually do is you can provide a window, like for session windows, you can actually provide a window of like 30 minutes, and then you look at this window and get the events, and then you start processing those events. And it again comes down to what kind of use case will actually provide you with what kind of windows you want to use, and how you get a watermark so that you process the events at the right time. But that's where it kind of comes down to. So even for event processing, you can use Flink, but then it comes down to what sort of marking you're actually doing on the events to make sure that you are processing the events in the right sequence, and you're processing the events in the way how you would like to process it. Any other questions?
How would you compare, from your experience, Kafka Flink and Apache Spark in terms of infrastructure side, cluster management, scalability, and resource management?
Right, is that a question from an AWS aspect or from general aspect?
General.
Okay, so in terms of management, the way I would look at it is what's actually currently happening in multiple environments and multiple customers is they're more going towards managed services, the way how you kind of, so let's say in terms of looking at Kafka, in terms of looking at Spark, in terms of looking at Flink as well, what you have is, I'm not too sure of the other services, but what you have is, I mean, this is basically on a general sense, take a step back and look at how do you manage infrastructure, be it running Kubernetes, be it running serverless and things like that. All of the cloud providers are actually trying to take the management overhead away from the customers. So you have an AWS managed service for Kafka where you don't have to worry about the cluster management. The cloud provider kind of does it for you. You have AWS managed service for Flink where you can actually run Flink on the managed service where the cluster management is actually taken out. And it's the same way for Kubernetes, same way for a lot of other functions as services as well. So, if you're looking at setting up your own Kafka cluster and how do you kind of manage that, I do see a lot of use cases where people are trying to go away from the cluster management, doing it manually, and more looking at how cloud providers kind of gives you that capability so that you can actually focus a lot more on how to basically build Flink apps and how to basically build Spark apps. So that's essentially what I see the trend going towards, not just on the data analytics app, but generally on. I work on containers as well. There's a lot of movement towards a managed Kubernetes service, a managed container service, and for that matter, there are a lot of services where people are moving towards running Spark apps on Kubernetes service. Is any of the customers are over here working on building Spark apps on container service? Because that's another great use case where a lot of customers I see are quite deeply interested in. For the very simple reason that if you have Kubernetes service, what you can then do is you can basically run Spark apps on top of it, microservice apps on top of it, and you can also run your machine learning models on top of it, which is basically, from a cost management perspective, it actually makes a lot more sense because you're using underlying the same instances and then repurposing it to make sure that you use the instances on the right apps. So rather than, usually analytics app works on a separate set of instances and your microservice app works on a separate set of instances. There's a strong adaptation which I see where all of these apps can actually coexist on a particular platform, and I do see customers moving more towards Kubernetes for that matter. So,
yeah, a couple more questions.
Thank you. This is a wonderful session. So you mentioned that, right? The Flink is dynamically for both the batch process as well as the streaming process. Yeah. So how, with respect to the business rules as well as the data quality perspective, so how will you do that in itself in Flink?
Yeah, so you can actually write your rules on your DAGs, right? So and then when it actually processed, it's actually on the in-memory. So most of your rules and the computation logic you can actually bring in within the Flink engine, because that way, for example, if you're actually loading into the database and then you actually compute it, and then it's going to actually give you the cost on that, and then they're going to actually charge you very much on it. For example, if you load on a Redshift and then you actually do the process on top of it, it's going to actually get you the cost of it. But if you actually do it on a compute engine during the processing, the stream processing, you can actually save, everything falls on the engine. It's actually on the network cost on the server, on the nodes. So you can actually manage that pretty well.
Okay, there will be some waiting time should be there, or like validating, because the streaming, right?
Yeah.
That's where I think that's where the concept of windows comes into picture. So you can actually define what sort of range you kind of want to wait before processing the events, or you can actually define, do you want to kind of do it on a seamless manner, or do you want to basically wait on a specific period to make sure that you get that series of event and then you kind of process that accordingly. So, I mean, for example, if you want to basically process page per views, that's where Tumble Windows kind of comes into picture, where you kind of stream it continuously. And if you want to process page per views for 10 seconds, then you kind of are looking at a different window. So in Flink, when you're processing event streaming, you basically then comes down to what sort of how do you want to measure the events before processing? So when we still talk about event streaming, but it does not necessarily mean that the moment an event comes, we process it and then we kind of take action against it. Depending on what level of use case we kind of come in, we then figure out what is the mechanism which we kind of need to use in Flink to making sure that we get the right set of events before. Because again, because it's an event streaming app, you cannot expect events to kind of comment on it. So for example, there's this concept called watermarking, and what watermarking kind of does is, when an event comes, there is two features with present an event. One is an event time, when the event actually happened, and one is an ingestion time, when the event is actually ingested into the Kafka. So what we tend to do is, when the event comes first, doesn't mean that the event has actually occurred, because there are cases where that particular event is ingested first, but the event time is probably at an later stage than the other event kind of comes in. So that's where watermarking comes into picture, where you kind of wait for a specific set of events to see which event actually occurred first, where you kind of look at the event time rather than the ingestion time, because the series of event is always based on what time it's ingested, never based on what time the event has actually occurred. So that's where you kind of look at a series of events and then see probably the event came at a later point in time, but the event time is actually earlier than the previous event. So you kind of have to process that first before processing the rest of things. So it kind of comes down to what you're really looking at from the use case, and then take a decision on what is the level of, what's the period which you kind of look at, what's the level of events which you kind of have to monitor before processing those aspects.
One more question.
I don't go there.
I was thinking what is happening during the downtimes, and if we have any data lost, if the stream is down, I don't know if the consumer is down.
Yes. You can take it if you want.
Sorry, that is a good question, but again, it kind of comes down to how you are actually managing the apps, because that's pretty much the same for any apps as well. So, okay, first of all, before we kind of get into how it actually gets processed, if you kind of compare it's processed through a batch app or a Flink app, it doesn't matter whether it's a batch processing or an event processing. It kind of comes down to how your events are being stored. Let's say, for example, if you're using Kafka streams, it then comes down to what is your retention period. So Kafka you can actually mention the retention period of how much the message should basically be stored. And so when the Flink app basically starts running, so because it knows where it has actually left, it can actually start again from set, and also the previous one which you kind of see, it kind of maintains the state of the application on a persistent storage. So you can actually start from where it actually stopped, because it would earmark, and this is also something supported in Kafka streams as well. So even on the same streams, if you have multiple apps listening to Kafka streams, what happens is each and every app earmarks at what point that event is processed, so that it can always go back and then start from there. So that's where the state is actually stored. But again, the question of when the app goes down, I would look at it more from a infrastructure perspective on why the app actually went down. And there are two reasons why an app could go down. One is the way how the cluster is set up or the cluster is managed is actually not at the right state where the app actually went down. Or two is it does not have the right size of instances. Or three is you're basically loading a lot of data in the memory rather than it's actually supposed to do. So I would kind of look at these three questions and then see how do we kind of tackle that. And that's also one of the reasons why a lot of customers go towards managed services, which then means that you don't have to handle the first questions. You only have to handle the second and third questions in terms of designing and making sure that you provide the right instances to the services so that those are actually taken care of.
I think we're gonna finish the event here. So thank you, Sri and Gokul, and the rest of our speakers as well. And again, thank you to Veronica for hosting us and providing the food and drinks for tonight. And yeah, we have another couple of minutes.